Hi everybody. So in this video, we're going to look at the chi-square test, and specifically how to use a chi-square distribution to perform a goodness of fit test. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So in the example, we're told that a restaurant manager wants to know if customers visit equally on weekdays. The manager collects data from a random sample of 75 customers over 1 week, recording which day they visited the restaurant. The manager expects the visits to be evenly distributed across the 5 days, and the observed and expected results are shown in this table. Using a 5% significance level, we've been asked to perform a chi-square test to determine if the number of customer visits is evenly distributed across the 5 days. So when we perform a chi-square test, the first thing we need to do is to state our hypotheses. This will involve a null hypothesis, which we call HO, and an alternative hypothesis, which we call H1. In this case, the null hypothesis will be that the observed visits fit a uniform distribution, and the alternative hypothesis will be that the observed visits do not fit a uniform distribution. So if we sketch the chi-squared distribution, and this is not symmetrical, so it's a skewed distribution, we need to identify the critical value, which will be about here. I'll label this as CV. And the area under the curve from a critical value to the right, this will be the significance level of 0.05. So I'll label this in the graph. This means that the rest of the graph will have a probability of 0.95, because we're looking at 100% of the data being underneath this curve. So when we're to the right of a critical value, this is where we reject HO. And if our test statistic, which we'll calculate in a minute, if this falls to the left of a critical value, then we do not reject HO. So our critical value is the line which separates whether we reject or accept our null hypothesis. So the first thing we need to do is we need to find the critical value within the context of this data. And to do this, we need to work out the degrees of freedom. Once we've got the critical value, we need to find the test statistic and compare its position to the critical value. If it's to the left, we won't reject HO, and if it's to the right, we will reject HO. So if we focus on the critical value, the first thing we need to do is to find our degrees of freedom. And this is the number of columns minus 1. So we have 5 days of a week. So we'll have 5 take away 1. We'll have 4 degrees of freedom. So we're looking at a chi-square test with 4 degrees of freedom at the 5% significance level. So if we go to our chi-square distribution table, this is in the Edexcel formula booklet, we have a degrees of freedom in this first column. So we're looking at 4 degrees, and we've got our significance level to the right of this, and we're looking at 5%. So if we go across from 4 degrees of freedom and then down at 5%, we're looking at a critical value of 9.488. I'll show this on our graph. 9.488. So this is our critical value. Now we need to calculate our test statistic. And we can calculate this using a formula, the sum of the observed values minus the expected values squared over the expected values. This is a formula given again in the formula booklet. So we'll calculate this from the data in the table. If we look at Monday, we'll have the observed value of 12, take away the 15 expected. So this will give us negative 3 squared divided by 15 plus for Tuesday. So 10 take away the 15, so negative 5 squared over 15 plus the Wednesday, 15 take away itself. This will give us 0. And then for Thursday, 18 take away 15. So plus the 3 squared over 15. And then for Friday, the 20 take away 15 will give us 5 squared over 15. And now we need to add each of these together. And we get 68 over 15, which works out to be 4.53 recurring. Okay? So it's important that we understand this is our test statistic. So if we compare this to the critical value on the chi-squared distribution, well, you can see this would fall to the left of that. We'll say that's about here, 4.53 recurring. And this is clearly in the do not reject region. So because the test statistic is less than the critical value, we'll say, therefore, there is evidence to support the manager's claim of a uniform distribution and not reject HO. So it's important that we write our conclusion back within the context of the original problem. So I hope that's given you an idea on how to perform a chi-square test. If you found that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.